Welcome everyone to this week's Weekly Space Hangout. I will be your fill-in host this week as Fraser Cain travels up and down the west coast of North America. I'm Nicole Gugliucci, also known as Noisy Astronomer, and I'm wearing a fedora, which is very exciting today. I have with me to my left, that side, Jason Major.
Hi, Nicole.
We have Dr. Pamela Gay.
Hello.
And Scott Lewis.
Hi, everyone.
Hi, everyone. So we are going to go through some space stories from this week. We have a little update on the Soyuz. Soyuz making it to the International Space Station. We're going to talk about Saturn. We're going to talk about star formation. We're going to talk about, unfortunately, we're going to talk about sequestration, but we're also going to end on a positive note, some things that we can all do to help promote space science in light of these events. And yeah, I think that's what we're talking about today here on the Space Hangout. If you have a question or a comment, you can comment on the YouTube page where we are broadcasting. You can also comment on the event page or pretty much anywhere else on Google Plus where you're seeing this video. And you can use Twitter, use the hashtag Space Hangout, and we will see that as well. So please bring us your comments, your questions. We'll try and get to those as we can. So we'll start with the Soyuz capsule. Last week, I think we had the Dragon capsule make its way to the station. This week, we had the Soyuz capsule make its way to the station. And so it is. Apparently took a little shortcut. What would normally be a 2-day flight, they shaved 6 hours off of that. So I guess
no, they shaved it down to 6 hours.
Oh, they shaved it down to 6 hours. Sorry, I read that wrong.
Yeah, it's way more exciting.
That's a big deal.
That is a big deal. I wish I could do that on my car trips. So yeah, 5 hours and 45 minutes after liftoff, they made it to the space station. So good on them.
I was saying on Twitter that's about as long as it used to take me to drive from Dallas to San Antonio, and
wow.
You know, they did 2 or 4 orbits. Anybody know?
That would be 4 orbits.
They did 4 orbits and then docked, and so that was 5 hours 45 minutes. That's
me flying from LA back home to Detroit.
Yeah, it's really amazing, and it's simply because they decided to do the lots of maneuvers required but get their fast approach versus the very cautious lots of if something goes wrong we'll still get their slow approach. And this was tested with 2 of the supply ships before they tried it with the human cargo.
Right.
And it worked.
They did it with, it looks like they did 3 test flights with the Progress cargo ships before giving them clearance to do this. And it means, 5 hours in a small cramped capsule rather than 2 days. So the cosmonauts must be pretty happy about that one.
And astronauts.
And astronauts. I don't know, who all is on here?
There's a little bit of everyone on board.
A little bit of everyone. And they get to meet Chris Hadfield sooner. That's fantastic.
Yes.
Here's a great shot that was taken from the ISS as the Soyuz was approaching. I think it was about 70 meters at the time of this image that was aired on NASA TV. So I mean, it was beautiful. I mean, it was a really, really nice nice docking maneuver. It was just fantastic to watch last night.
I love the Soyuz. I mean, I love the Dragon capsule. I've been there. I've seen it up close. But for some reason, I just love the way that the Soyuz capsule looks.
It's got a slimmer waistline.
Yes, it does.
It has history.
It has history as well.
It has history.
Yeah. Don't redesign what works. That's what the Russians have stuck to. Is they just keep adding innovation onto the existing model. It's kind of like the Mustang of spaceflight. Well, not Mustang, really. It's more like the pickup truck of spaceflight. But
isn't that what Soyuz means in Russian? If it ain't broke, don't fix it.
Pretty much.
Yeah. Why can't we get to Mars, I think is what it means.
Oh. Robert Herrick asks, what makes this new flight so much faster? And I think, Pamela, you mentioned they went for more maneuvers, so they're using more fuel to get there. And that's what makes it quite a bit faster.
And they were also much more cautious about launching during a very small window that allowed the alignments of where the space station. Sorry, I'm fighting terrible allergies today, so you're getting a Benadryl haze during this report. So they were much more precise about making sure that the orbits would precisely line up just right, so that less catching up was required.
So is this going to, do we know if this is going to be standard now, or?
That's kind of the hope.
Okay. Because with a smaller launch window, you can run into more problems actually launching during that window with weather and whatnot.
It just means you delay launch if you screw up. We're used to that.
Yeah.
There's been many instantaneous launch windows. Grail had to deal with that, for instance. So trying to get Grail off the ground, there were these instantaneous launch windows in order to get to the moon. And so that was an interesting challenge as well.
I'm sure the astronauts and cosmonauts would rather wait 24 or 48 hours on the ground for another launch than, you know, be up in the capsule for 2 days.
You could get out and stretch. And Scott, I think you have a story that goes along with this one.
Yes. Speaking of Soyuz and the amazing spacecraft that the Russians have been using for a long time, there's this fantastic young woman from the U.S. Her name is Abigail Harrison, and she's 15 years old. She has her website called astronautabby.com, and she is going to Kazakhstan for the next launch going out in May. So she's been working with ESA. She has a mentor out there to where she's going to be there for the launch. She's going to be there for a few days beforehand. She is going to be there as a freelance journalist, so she's going to be like after our own hearts, writing about it and sharing her story with the world. And it's just amazing how she's been, you know, her story, and she's been picked up on Wall Street Journal and USA Today and all over the place, and she's been really engaging on, you know, on being excited about what's out there. And she's already made the decision that she's going to be the first astronaut on Mars. That is her goal in life, is that she is going to be the first astronaut. So watch out, Elon Musk. We have someone that is going to just blow you out of the way and get there first.
Or get on his spacecraft.
Yeah, maybe there's a collaboration that could be working here. But, you know, she's been really, really great. And right now she's also doing a lot of education public outreach with different schools across not only the United States but the world. So she's got a Rocket Hub campaign that has a goal of 35,000. She's about a seventh of the way there right now. But it ends in the middle of May, so there's more than enough time to get all that going. But she's just announced this whole big project going on with going to Kazakhstan and being able to share her exciting journey of not only just being in love with space and going to space, but also being involved with the process of the astronauts and cosmonauts that need to go through the process and everything going up to the launch day itself, even up into a few hours. She's going to be up there until a few hours talking with the entire crew until they go up into space and join up with the ISS. So it's really exciting, and she's just been a phenomenal role model for everybody, an inspiration for everyone.
A fantastic opportunity for a high school student. I mean, I can't even imagine, you know. And she's been very active on Twitter, at least as long as I have, if not even longer. And I mean, it's always enthusiastic, it's always positive, it's always excited, and you know, having her there and reporting on all of this is going to take or give a great young person's viewpoint into all of it.
Absolutely. I was first made aware of her when she tweeted me when Pamela took a picture of Tony and I behind the scenes at the NASA media room at South by Southwest, and it was like, oh, it's a really cool picture. And so we just started talking here and there. We're going to try to get her on a hangout, but she's now really active here on Google Plus as of like a week and a half ago. So I'm really hoping that we can get her engaged on our end on G+, as well as Twitter and her blog and things like that. So I'm really excited to see and being able to share with the world what she's doing. She's really an inspiration to all of us.
That's cool. I admire her a lot, because 15 was around the time, when I was 15 years old, was around the time I gave up on my dream of being an astronaut. So the fact that she is going full force into this is fantastic. So yeah. I'm going to live through her. I'm just going to live through her.
That's right.
That's so cool. That's so cool. We got a question that's sort of related to these things. Rob Ross on YouTube asks, His words, not mine. Why did we go with the Tinker Toy construction pattern for the ISS instead of a way cooler rotating space station like in the movie 2001? Couldn't we have built that over the last 20 years?
No. No, the actual problem is that in order to get one of those beautiful, round, elegant structures, you have to have beautiful, round, elegant substructures. And when we built the International Space Station, it was built out of modules constructed here on the surface of the planet and launched into space. And all of our spacecraft are kind of straight rather than curvy. And in fact, if you think about the shape of a rocket, they're really, you don't want to build a rocket that's appropriately shaped to launch a section of an arc. So when we look towards a future where we will hopefully have either the Babylon 5 model of giant cylinder rotating, that's the future I want, or the Arthur C. Clarke donut rotating, those are really things that need to be built on orbit. And that's a future we can imagine when we start thinking about capturing meteorites that can be mined and building things in space. But as long as we're building things on the surface of the planet, we're going to be building things out of either inflatables, which is the direction Bigelow's going, or we're going to be building them out of, well, Tinker Toy construction, or I think this is much more like the magnetic connects.
Yeah, I think the inflatables, Amy Shira Teitel, who couldn't make it this week, has talked about the history of the attempts with inflatables in space flight. So that is a cool article. You should check that out. So thanks for the question. And yeah, design challenge, we don't have the resources, it sounds like, to deal with yet.
Just see another comment. Bananas do not make good rockets. No. Bananas do not make
They're
good
like boomerangs. They're like boomerangs. They'll just come back.
Your comment stream must be faster than mine. I haven't seen that one yet.
Thank you, Will.
Fantastic.
Will, that was awesome. Yes.
Awesome. All right, let's move out a little bit further now to Saturn. We have some new analysis of data from the Cassini mission. Jason, did you want to give a stab at that?
Well, yeah. I mean, you know, Saturn's awesome. We all know Saturn's awesome. Saturn's like Jupiter, has a bunch of moons. I think 62 named moons as of this date. But Saturn just got a little bit more awesome because it turns out that the moons probably had formed around the same time as all the other bodies in the solar system out of the same protoplanetary disk. So, well, you know, where else would they have formed? Well, they could have been. They could have formed from impacts that happened around Saturn and then coalesced into other moons. You know, there are other ways where a planet of that size could gather moons. I mean, even Earth's moon formed after Earth formed. You know, there was an impact and stuff got sprayed out into space, and you know, maybe formed a couple moons and ended up where we have the one that we have now. But Saturn's family of moons formed all around that same time, which means that to look at the Saturn system with Cassini and with other spacecraft means that you're looking at kind of like a little mini model of the solar system. And even though the moons, as we see them now, they have some different colorations and some different surfaces and some different compositions, a lot of the stuff that's on the surface is just that. It's just surface stuff. It's micrometeorite impacts. You know, they gather up things as they get struck by other bodies that are flying around the outer solar system. But deep inside, a lot of these moons have the same type of water ratio as was in that area of the solar system when the solar system itself was forming. Now we're going back 4.5 billion years. So, you know, it's kind of like saying, hey, guess what? Saturn's moons are old. Well, yeah, no kidding. Of course they're old, but you know, they're actually going back to that point in time. So to study them is to study what the solar system was, and they've evolved along with the entire solar system. So, you know, that's an exciting thing, and it just gives another reason to go out to Saturn, to look at it, to send more missions out there. You know, not just to peek underneath Enceladus's crust or to see, you know, what's going on Titan's lakes, but also to study the evolution of the entire solar system. So that's some pretty cool stuff.
Oh, go ahead.
And this leads credence to the notion that many of Saturn's moons are nothing more than captured Kuiper belt objects, captured comets, captured asteroids that it was able to gravitationally grab onto. So we're now seeing moons as having two different formation mechanisms. There's moons like our own moon that formed later. Ours is the result of a rather nasty impact. And then there's also moons that are primordial bodies that were then captured and became moons. Phobos and Deimos around Mars were known examples of this, and Jupiter has several unusually shaped objects. Triton is another one.
Trojan satellites are so cool.
Yeah, so now we're finding that Saturn is yet another thief rather than former.
Well, I thought it was suspected that gas giants had their moons form around them like mini solar systems. Is that not the case for the larger moons? I know it's not the case for Triton.
It's completely unclear. Okay. That's one of the crazy things, is it's simply completely unclear. Gotcha.
Well, and this is more evidence for, the particular age, which may point to a mechanism.
Yeah.
Definitely, maybe.
One thing that it is showing, and I've got a photo here as an example, is that the different surface variations that we see on Saturn's moons is really just, it's just what's happening on the surface.
Yeah.
So it's not indicative of entirely different types of formation. They all kind of formed around the same time. What we see here is a picture of Iapetus. Now, Iapetus has two different color surfaces. The darker side, and correct me if I'm wrong, the darker side is forward-facing, and the lighter side is rear-facing. But the material kind of moves around it depending on how it sublimates and then ends up on the other side. Yeah. So it kind of drifts around. But it also has a reddish surface. That reddish material can actually be coming from other moons and other things that are landing on it. So the variations are just basically just that. They're just surface stuff. They're just kind of decorations. The guts of the moon are what was out in the solar system, 4.5 billion years ago.
Yeah, and Saturn's thinking of word. Can't think of appropriate word. Saturn is a good place for such pollution because of its ring system, and so I think that's the point with Iapetus, which looks like the Death Star, but I thought Mimas was the Death Star.
There's a lot of moons that kind of look like the Death Star.
Okay.
Yeah.
I got confused for a second there.
This is not the Death Star you're looking for.
No. What's awesome is all these Death Stars, these are worlds that have clear resurfacing because you have that one mammoth crater and then not a lot of other craters.
Yeah.
And so that lack of having bazillions of craters indicates there's some sort of resurfacing taking place. So there's science in finding Death Stars.
Yes, science and sci-fi, which we'll get to a little later. But first I want to talk about, moving out a little further now, talk about star formation with the Herschel Space Telescope. And I'm going to put the link in the comment thread so you guys can look at the gorgeous, gorgeous picture from Herschel, which is an infrared space telescope. And this is looking at star formation, which, although we understand the basics of star formation, which is gas collapses, star ignites, you get nuclear processes in the core as soon as it's hot and dense enough. The details of it are actually still very much a mystery. It's still more a cartoon model to astronomers. And so this is showing a star formation process it's these particularly large stars. And I love the headline that Ian ONeill came up with. Fattest stars are force-fed at an early age. Basically what's happening is these very large stars get their gas from older stars around them. So as stars age, they often lose their outer envelope of material. They can either blow up, large ones blow up in a supernova, or smaller ones kind of huff off their material to be used in later generations of star formation. So if you have these older stars nearby, as in the case of this research here using Herschel, there's the picture. Thank you. Let me see if I can highlight that. Yay. Okay.
That's pretty.
So what you're getting is that gas is being directly fed onto these newborn forming stars, and so these really young, really massive stars are in a way being fed a little faster than they would had those older stars not been there. And
this image here is of an area in the in the Perseus arm of the Milky Way, about 6,200 light years away.
Right. And you need the infrared telescopes to look at this star formation region because star formation is often surrounded by a lot of dust. And so that blocks the optical light. And so we go to the infrared, or, of course, I'm going to bring this up, the radio. Okay, I was in Chile for a week.
Or, the James Webb Space Telescope.
Yeah, but that's not done yet. All of that's done. You can use, infrared like the James Webb Space Telescope, like Herschel, like Spitzer, or like ALMA, which is looking at millimeter wavelengths and peering through that dusty veil to see star formation as it's happening. I'm sorry, I have to bring it up.
It's fine. And what's kind of interesting is this all breaks down to basically a pressure balance situation where you have these young, really hot stars that if they're isolated, as material tries to fall in, it just pushes it away. And so there's this maximum point at which they can't grow anymore because the light pressure pushing out is greater than the gravitational pull on material that might be trying to fall in. Quasars have the same problem. There's actually an upper limit to how big supermassive black holes can get that has the exact same physics. I love the fact that physics works at so many different size scales.
Yes.
Now, in really dense clusters, you may have older stars that are pushing out material, and if you surround one young star with a bunch of old stars that are pushing on it with material, that external push plus the gravity can force additional material onto the young star. So it's basically the force-feeding approach to getting fat stars.
Nom, nom, nom.
Yeah, it unfortunately makes me think of foie gras. So
that's exactly where my brain went too.
Yeah. So it's not a pleasant image, but it's how you get bloated stars.
Pamela, is the composition the same in a star that's being force-fed material and being force-fed, I guess, just I mean, does it end up with a slightly different composition than a similarly sized star?
So the way to think about it is a star's composition is based on the number of generations of material that have been able to form it. So stars in general are made up of the material coming off of older stars. Now, was that isolated star not surrounded by old bodies? It might not have as much enriched material in it. It depends on what its original star-forming cloud is. So it will be taking in compositionally enriched materials, especially that have been enriched with the slow S-process elements that are created in the atmospheres of these older stars. So there'll be extra carbon and things like that. But you can't really say, I can tell this star based on its composition was enriched due to force feeding. It's just, yes, it's natural. It collapsed gravitationally out of this material, will potentially be enriched by material of a different composition being forced onto it. But that's no different than saying those stars blew off their stuff and then it formed.
Yeah, in this case, we're seeing directly the generation before it giving its material onto it, but that process is always happening, although you can't directly see what stars gave off that material. But we can tell a lot about the age and history of galaxies based on well, we're going to use the term metals, anything heavier than hydrogen and helium, to astronomers, based on the ratios of those heavier elements. Cool. And that's where we come from. Yay.
Yay. Nucleosynthesis.
Nucleosynthesis. Okay. Unfortunately, I think we have to move on to some darker, sadder topics. I guess not long after this Hangout broadcast last week, there was a leaked memo from NASA about sequestration. Maybe Pamela can talk more.
Yeah. So I spent last week down at the Lunar and Planetary Sciences Conference where I was meeting face to face with a lot of the liaisons I have for various NASA products. And while the memo didn't come down until Friday, we knew that something was coming based on spontaneous requests for reports that aren't part of our standard reporting. And when you're given 48 hours to sum up all the research you do in 2 pages or less, you know something's going on. So Friday, I was driving home from the conference and got a phone call asking if I was on Facebook. And I responded, no, I'm driving. And the person I was talking to said that she thought she just found out she lost her job from Facebook because the leaked memo, which I can confirm is true, said that all NASA education and public outreach activities were to cease immediately. Now, this wasn't a cancellation, this was a suspension. And what's happening is, because of sequestration, pretty much all government agencies need to figure out how to institute something on the order of a 9% cut in their funding. And NASA isn't in a position to cut 9% of the Hubble Space Telescope or 9% of the Lunar Reconnaissance Orbiter. These are orbiting spacecraft, roving spacecraft. They have set funds, and so you can't really touch them without destroying the future of what we can do scientifically. So you have to look for other places to make cuts. The first place that NASA made cuts was 2 weeks ago. They sent out a memo that froze all travel. There was going to be no more travel that wasn't grant related. And this meant that a lot of people had to quickly try and get waivers to go to the conference last week. It meant that folks like John Grunsfeld and Jim Green, who are basically our bosses at NASA HQ, they weren't able to attend the meeting because what they were doing wasn't mission critical. They could Skype into the meeting, and they did Skype into the meeting to communicate with us. But cutting travel doesn't cut 9% of NASA's budget. So they kept looking for places where they could make changes that allowed the science to keep going. And the place that they identified was to stop all non-grant related outreach. Now, the problem is no one fully understands yet what this means. There was a very confused telecon on Wednesday to which we heard the quote, and I'm not going to attribute the quotes, but the quote was, "No one knows what the hell is going on, so don't panic." And so there's a lot of conflicting messages where some people have been told that they are to cease all EPO activities immediately and apply for waivers. Other people have been told to continue on with what they're doing. And we're all waiting for the dust to settle. And it's a very scary time because we know some of us will lose our jobs. At CosmoQuest, which is one of the sponsors of this program, we know that all of our media-related staff, because they're not funded by NASA, are safe. So Scott is safe. We know that people who are funded on grants are safe for now. So Nicole is safe. Part of my salary is safe. Our education staff is safe. What we and what all of the other people who work for missions don't know is, well, what's going to happen to mission EPO? We're just not sure yet. So in order to try and prepare, knowing that there will be people who lose their jobs, we are, through CosmoQuest, working to raise money to both keep our own programs going, and then when we find out people who are doing amazing work are no longer being paid to do that amazing work by NASA, we're going to work to find ways to contract them as we are able through your donations to keep the NASA outreach going, to keep the education of science going. It's an ugly future, but the thing is, we all have the ability to change the future and make it what we want it to be. And CosmoQuest is going to try to raise the money to be a safety blanket. And we've already reached out to individuals who are in particular jeopardy and said, hey, how can we help? And what's been kind of amazing is we've had some people reach out to us and say, at the corporate level, how can we help? There's going to be at least one Kickstarter and possibly one Kickstarter and one other crowdsourcing program getting posted in the next week or so. I'm just trying to work out the details right now.
Yeah, so it's a scary time, but not completely hopeless. I think that's the thing to get away from this. I posted a link to your blog post, Pamela, on CosmoQuest about how we're facing down sequestration and the start of the campaigns that we're doing to raise money. Your tax dollars have provided an amazing amount of NASA EPO and science EPO, education and public outreach in general, but we're losing that. And so if you want to see these programs continue, it looks like private money is going to have to come in, and whether this is from large donors or from crowd-funded projects in the future, I think has yet to be seen. I had this sudden insight driving to work the other day, like, oh my God, EPO needs its own Elon Musk, right? You know, I mean.
Well, and the other day I had someone ask what it would take to secure the future of CosmoQuest, and I realized this is going to sound to us education folks like a huge amount of money, but $10 million would provide us an endowment that would allow the bare minimum functions of what we do at CosmoQuest today to keep going permanently into the future. And then I realized McDonald's spends $100 million advertising Happy Meals.
Yeah.
And it was no longer that large a piece of money. For now, I want to raise the $20,000 to make sure our graduate student is paid for through the entire year, because I hate to say it, but it's our programming team that's most in jeopardy. And I want to keep raising money to keep the entire community safe.
Yeah, no programming team, no CosmoQuest. The website does not run on its own. Pamela can only do so much, as well as everything else. So when this started happening, we didn't know grant funding was safe right away, and so I got this email Saturday morning as I was about to judge science fair. It's like, don't be a downer for the kids. I may not have a job next week, but I'm not going to be a downer.
Think of the children.
Think of the children.
Yeah.
But,
and at the end of the day, that's the thing, is if no one is taking the science results that NASA is coming up with and communicating them out at a way that teachers can use them to get them into the schools, how are we going to have a next generation that is scientifically literate? If you want to find out more and you're not checking the comments, it's cosmoquest.org/blog, and there's actually a donate link in the sidebar.
So,
I think a big thing to focus on too is that we all work in different aspects. Like this show, for instance, is something that comes together from places from all over the place that are volunteering their time. We have a lot of fun working together, and we do it because we love space, we love astronomy, we love being able to share that with everyone. And a lot of stuff that we do is extra on top of our core duties because we do love sharing this with everyone. But when it comes down to our core funding, our day jobs possibly being cut out, it takes away from the extra stuff we are able to do, like the Google Plus Hangouts and things like that. So it's something that we love and we really, really want to keep doing. This is something that I don't see myself stopping anytime soon, but it just makes it more difficult for us to keep roofs over our heads while we go forward doing the same things we've always been doing. Yeah,
it is highly stressful. My salary over the past 5 years has oscillated up and down by a factor of 2 as my grants have come and gone. And luckily I have a husband who can pay our mortgage. But doing what we do is an odyssey of love. But it should never be something we do because we've taken a vow of poverty, but it often feels that way. I'm reminded of Brittany Schmidt in an interview she did with Emily Lakdawala. Brittany is an outstanding scientist. She is the person who figured out how to transport liquid to the surface of Europa using hydraulic pressure. She's a brilliant scientist who, despite being in her early 30s, can't imagine anything other than a crap apartment because as a leading scientist, she is paid so poorly. And she looks at her friends who have bachelor's degrees, who are doing just regular everyday jobs, buying houses, buying cars, living these great lives. But it's our most intelligent scientists who are expected to never earn that much. And the people who take those results and use them to educate the public, we live 6 months at a time on our funding, hoping that the next 6 months of funding will come in.
It's nice to think that if I wasn't getting paid, if I didn't have to worry about the bills, I would still keep doing this because it's awesome. I really like my job. But now I'm paying the rent for, 2 people until my partner gets employment. So, that does come into consideration. But I can decorate really nicely on the cheap. See, I have a target.
So anyways, we are now at the stage of depressing rant, and
yes.
My coffee only has caffeine in it and nothing more interesting.
Okay, so let's move on to more exciting. Well, you mentioned the CosmoQuest is fundraising. I wanted to put in a quick plug for an Indiegogo campaign called We Are the Explorers.
Yes.
If you follow Will Wheaton, you've already seen this. This is a campaign to get a 30-second spot in front of Star Trek Into Darkness, which is coming in soon. I'm very excited. But a 30-second plug for NASA in the beginning of this movie, which, millions of people are going to go see, people who are already sci-fi enthusiasts, to help inspire them. And this is one way in which private funding is going to take up that mantle. So go check it out. We Are the Explorers. I'll put a link to that as well.
And the original video is amazing. They're going to cut it down to a 30-second spot, but by all means, go watch the video. It gives you chills watching it. Because it's got Optimus Prime talking about NASA.
Oh, that's what that was!
Yes, it's Optimus Prime.
Totally
And it's NASA, Transformers, in the beginning of Star Trek. What more could you want?
Lightsaber.
Yes.
Yeah. And the thing you have to remember is NASA and other federal agencies are not allowed to spend money on marketing, on advertising. They're allowed to educate, but that's the limits of what they're allowed to do. So something like this that will expose so many people to inspiration, this is something that you have to pay for because NASA and your tax dollars aren't allowed to.
Yes.
That seems really strange too, because I can't even say how many ad spots I've seen for, say, various armed forces. So you see, you see the Air Force and the Army and the Marines, and
those are recruiting for hiring positions.
Well,
so you're allowed to advertise job openings. That's a different thing. And so if you put that in the context of looking to hire new people, that's something you're allowed to do. You'll also see in Washington, D.C.
Isn't that what they need to do in NASA? They need to
I've never seen a commercial like that for postdocs.
Well, that's because you don't need to advertise for postdocs. If you hint accidentally, you might have funding for a postdoc. 40 PhDs come out of the walls going, I need a job.
It's so true. It's right? I mean, I did that to you.
Yes. And it got you a job. So I don't need to spend money looking for postdocs. I need to, tweet.
It's true. It's unfortunately true. All right. So now that we're back in a laughing mood again, I'm going to go back to Jason, who has a very cool book review and a chance to win this very cool book that's coming out. So take it away.
This is fantastic. It's a new space book coming out next. Actually, I believe it's next Tuesday. It's called Your Ticket to the Universe: A Guide to Exploring the Cosmos. It's by Kimberly Arkan and Megan Watsky, and they are both members of the NASA Chandra X-ray Observatory team out of the Harvard-Smithsonian Center for Astrophysics in Boston. And so, as Chandra team members, they are, very well versed in awesome space images. They've over the past decade, they've put together some really great programs called From Earth to the Solar System and From Earth to the Universe, which set up public displays of a lot of really nice space exploration images. So those have been in thousands of locations around the world. So they've put together this book to basically bring a lot of those images and put them in your lap. And I'm telling you, when I get a copy of this in glorious full color, I was just really blown away. I mean, there's images here from the space station. There's images here from NASA's Solar Dynamics Observatory. It goes from the solar system all the way through. We got birth of stars. I mean, it goes through the galaxy. A lot of pretty stuff like this. And what's nice is that the text throughout is conversational. So to read this, it's like having Kim and Megan sitting across from you, having a cup of coffee, and telling you all about the stuff in ways that anybody can understand. And I love that. I love that's kind of outreach in its own right. It's getting people excited about space. Some of the most exciting things about space are the images that come into a lot of the exploration missions and the telescopes that see things that we can't see, but they make it so that we can, and that we can understand, what's happening in the center of the galaxy, what's happening around black holes, what's happening in Jupiter's clouds that our eyes can't see, but these missions can. So they go through the whole thing. I mean, it's basically, starting at Earth and going all the way out to the edges of the visible universe. It's a fantastic book, 240 pages, images all over the place, photos throughout, and it comes out next Tuesday, April 2nd. And if you want to check it out, you can go to yourtickettotheuniverse.com. You can also look at my review on Discovery News, which is news.discovery.com. And there's also a giveaway going on at Universe Today. They have a few copies to give away, so if you jump over there, I think, Nicole, you have the link put up there, so they can enter to win a copy of this. So that's a great addition to anybody's space library. I'm proud to be helping them promote the book. So
excellent.
And if you don't already know, Kim and Megan are actually the people who are behind From Earth to the Universe in the International Year of Astronomy, and From Earth to the Solar System through NASA's 16-month-long Year of the Solar System. And so these are two amazing women who are making a career out of sharing spectacular imagery with the public in all of the places you do and don't expect to find it.
I've been at some presentations by Kim, and I mean she can just hold a room full of people spellbound, showing them how, for example, they put together some of these color images from Chandra. So I mean she does a fantastic job at describing really complex stuff in a way that you walk away and you go, oh, I get it. I understand it now.
Yeah, they're both very different people who captivate rooms in amazing ways.
That's very cool. I will have to stop making fun of X-ray astronomers now.
As you should.
Shame on you.
It's just the other side of the.
There's higher energy. Come on.
They're counting photons. It's
fine. And there's shorter wavelengths. And what do you have against short people? Okay.
Hey.
Okay. So we've got a couple comments. I want to remind you guys that you can comment on YouTube, on the Google Hangout page, or on Twitter with the hashtag #LearningSpace. Not LearningSpace, Space Hangout. Sorry, I'm just hosting on Wednesday. There's a good comment from Robert Scott Herrick saying he would put the We Are Explorers trailer in front of something like Iron Man, where kids can be stoked to see the technology at work. Because might be preaching to the choir, and I agree with your first part. I don't know about the second part. My experience at sci-fi conventions is a lot of people are gung-ho about sci-fi, don't quite know what's going on in science or astronomy or space flight. So keep getting there's an easy hook there, but they're not in the choir yet necessarily. So
one of the things with sci-fi is, and I love sci-fi, of course, but when you have people who really like movies and really like science fiction, but don't know a lot about the science behind it or what's actually happening in real space exploration, is when they do see something that's news in space exploration, they're not excited about it because it doesn't live up to the glamour of the special effects and everything that they're used to seeing. So in their mind, that's already happened.
They need to watch more Firefly and understand explosions are silent.
Right.
There are no lens flares in our images for good reason. Sorry, J.J. Abrams, I love you, but come on.
I think too is is when you start understanding the science of the universe, it blows special effects out of the water. When you're able to actually visualize what's happening, and you can see it just unfold in front of you just by having a general understanding of the science going on. Any sort of special effects will pale in comparison to what your mind's able to understand when you actually learn what's happening.
And Star Trek has become a bigger cultural phenomenon than just us little sci-fi nerds. So, you know, there's that as well. It's going to get big numbers no matter what. It's going to get big numbers on opening weekend. So it's crowd draw. So it's entertaining. What can I say? All right, I think that about wraps it up for this week's Space Hangout. Thank you, everyone, for watching. We'll go down the line saying where we can find more of you, starting with Jason.
Well, I live over at lightsinthedark.com. I'm also on Universe Today, Discovery Space News, and you can find me on Twitter at JPMajor.
Cool. And Pamela? Oh, Pamela, you're muted. Can you guys hear her?
Nope.
Okay, we can't
muted.
hear you.
Sorry, mute. I'm muted. I'm sniffling allergies. I'm mostly at cosmoquest.org. You can also find me as at Starstrider on Twitter.
You are Twitter.
I am Twitter. No, I'm at Starstrider, spelled with a Y, and my personal blog is starstrider.com.
And Scott Lewis.
Everywhere.
Where can we find your gorgeous bald head?
My bald head. I am Google Plus at Plus Scott Lewis. I am on Twitter at Bald Astronomer. My personal webpage is knowthecosmos.com, but also with Astrosphere New Media Association and CosmoQuest and Virtual Star Party everywhere.
All the places, all over the universe.
All the places.
He does all the things.
And yeah, Science Sunday Hangouts too. We're working a lot with Science Sunday now too.
Excellent. And I am Noisy Astronomer. I also work for CosmoQuest, and I'm going to put in a plug for my own video because I spent a lot of time on it. If you go to my YouTube channel, look for Noisy Astronomer. I just put up a about 8.5-minute video of my trip to the Atacama Desert in Chile. So go check out one of the coolest radio telescopes in the world.
I'm going to tweet that right now.
Thank you.
I will retweet that.
I love you guys.
I'll retweet as well.
We'll do this because I really want to get this out there because the NRAO paid to get a bunch of us space journalists out there to 16,000 feet, and so I want as many people to see how cool that was through our lenses. So awesome. Thank you for watching, everyone. The next hangout is Sunday night, Virtual Star Party. Do we have a time for that, Scott?
I need to still confirm with Fraser because Fraser is in town and we will be meeting in Meet Space at Gary's. Yes. Surprise! So it's going to be great. Like twice this month, I'll be doing a virtual star party with Fraser in Meet Space.
Okay.
But before that, at 3 p.m. Pacific, speaking of the Science Sunday Hangout, Budini and I will be doing a panel discussion about ENCODE, which is the Encyclopedia of DNA Elements, and this new research that's going on and better helping understand the Human Genome Project and what's going on with the quote-unquote junk DNA. So
cool. All right, so we have DNA and Virtual Star Party on Sunday. Check those out. And then the whole weekly lineup starts again. Pamela, do you guys have Astronomy Cast on Monday, or is that on hold till Fraser stops driving around the country?
I need to find out where Fraser's going to be on Monday. I think we may be recording. I'm not sure.
Okay, but we'll definitely have a Learning Space Hangout on Wednesday afternoon. So thanks for sharing our space news hangout with us, everybody. Have a good week.
Sounds great.
Hey, guys.
Bye, everyone.
Have a good weekend.
So they were much more precise about making sure that the orbits would precisely line up just right so that less catching up was required.
So is this going to, do we know if this is going to be standard now, or?
That's kind of the hope.
Okay. Because with a smaller launch window, you can run into more problems actually launching during that window with weather and whatnot.
It just means you delay launch if you screw up. We're used to that.
Yeah.
There's been many instantaneous launch windows. Grail had to deal with that, for instance. So trying to get Grail off the ground, there were these instantaneous launch windows in order to get to the moon. And so that was an interesting challenge as well.
I'm sure the I'm sure the astronauts and cosmonauts would rather wait 24 or 48 hours on the ground for another launch than, be up in the capsule for 2 days.
You could get out and stretch. And Scott, I think you have a story that goes along with this one.
Yes. Speaking of Soyuz and the amazing spacecraft that the Russians have been using for a long time, there's this fantastic young woman from the U.S. Her name is Abigail Harrison, and she's 15 years old. She has her website called astronautabby.com, and she is going to Kazakhstan for the next launch going out in May. So she's been working with ESA. She has a mentor out there to where she's going to be there for the launch. She's going to be there for a few days beforehand. She is going to be there as a freelance journalist, so she's going to be like after on
that one.
And astronauts.
And astronauts. I don't know who all is on here.
There's a little bit of everyone on board.
A little bit of everyone. And they get to meet Chris Hadfield sooner. That's fantastic.
Yes. Here's a great shot that was taken from the ISS as the Soyuz was approaching. I think it was about 70 meters at the time of this image that was aired on NASA TV. So, I mean, it was beautiful. I mean, it was a really, really nice, nice docking maneuver. It was just fantastic to watch last night.
I love the Soyuz. I mean, I love the Dragon capsule. I've been there. I've seen it up close. But for some reason, I just love the way that the Soyuz capsule looks.
It's got a slimmer waistline.
Yes, it does.
It has history.
It has history as well.
It has history.
Yeah. Don't redesign what works. That's what the Russians have stuck to. Is they just keep adding innovation onto the existing model. It's kind of like the Mustang of space flight. Well, not Mustang, really. It's more like the pickup truck of space flight. But
isn't that what Soyuz means in Russian? If it ain't broke, don't fix it.
Pretty much.
Yeah. Why can't we get to Mars, I think is what it means.
Oh. Robert Herrick asks, what makes this new flight so much faster? And I think, Pamela, you mentioned they went for more maneuvers, so they're using more fuel to get there. And that's what makes it quite a bit faster.
And they were also much more cautious about launching during a very small window that allowed the alignments of where the space station. Sorry, I'm fighting terrible allergies today, so you're getting a Benadryl haze during this report.
And so it is. It apparently took a little shortcut. What would normally be a 2-day flight, they shaved 6 hours off of that, so I guess...
No, they shaved it down to 6 hours.
Oh, they shaved it down to 6 hours! Sorry, I read that wrong.
Yeah, it's way more exciting.
That's a big deal.
That is a big deal. I wish I could do that on my car trips. So yeah, 5 hours and 45 minutes after liftoff, they made it to the space station. So good on them.
I was saying on Twitter that's about as long as it used to take me to drive from Dallas to San Antonio, and
wow.
They did 2 or 4 orbits? Anybody know?
I don't know.
That would be 4 orbits.
They did 4 orbits and then docked, and so that was 5 hours 45 minutes. That's
me flying from LA back home to Detroit.
Yeah, it's really amazing, and it's simply because they decided to do the lots of maneuvers required but get their fast approach versus the very cautious lots of if something goes wrong we'll still get their slow approach. And this was tested with 2 of the supply ships before they tried it with the human cargo.
Right.
And it worked.
They did it with, it looks like they did 3 test flights with the Progress cargo ships before giving them clearance to do this. And it means, 5 hours in a small cramped capsule rather than 2 days. So the cosmonauts must be pretty happy about that. Welcome everyone to this week's Weekly Space Hangout. I will be your fill-in host this week as Fraser Cain travels up and down the west coast of North America. I'm Nicole Gugliucci, also known as Noisy Astronomer, and I'm wearing a fedora, which is very exciting today. I have with me to my left, that side, Jason Major.
Hi, Nicole.
We have Dr. Pamela Gay.
Hello.
And Scott Lewis.
Hi, everyone.
Hi, everyone. So we are going to go through some space stories from this week. We have a little update on the Soyuz. Soyuz making it to the International Space Station. We're going to talk about Saturn. We're going to talk about star formation. We're going to talk about, unfortunately, we're going to talk about sequestration, but we're also going to end on a positive note, some things that we can all do to help promote space science in light of these events. And yeah, I think that's what we're talking about today here on the Space Hangout. If you have a question or a comment, you can comment on the YouTube page where we are broadcasting. You can also comment on the event page or pretty much anywhere else on Google Plus where you're seeing this video. And you can use Twitter, use the hashtag Space Hangout, and we will see that as well. So please bring us your comments, your questions. We'll try and get to those as we can. So we'll start with the Soyuz capsule. Last week, I think we had the Dragon capsule make its way to the station. This week, we had the Soyuz capsule make its way to the station.
Our hearts writing about it and sharing her story with the world. And it's just amazing how she's been, her story, and she's been picked up on Wall Street Journal and USA Today and all over the place. And she's been really engaging on, on being excited about what's out there. And she's already made the decision that she's going to be the first astronaut on Mars. That is her goal in life, is that she is going to be the first astronaut. So watch out, Elon Musk. We have someone that is going to just blow you out of the way and get there first.
Or get on his spacecraft.
Yeah, maybe there's a collaboration that could be working here. But she's been really, really great, and right now she's also doing a lot of education, public outreach with different schools across not only the United States but the world. So she's got a rocket hub campaign that has a goal of 35,000. She's about a seventh of the way there right now, but it ends in the middle of May, so there's more than enough time to get all that going. But she's just announced this whole big project going on with going to Kazakhstan and being able to share her exciting journey of not only just being in love with space and going to space, but also being involved with the process of the astronauts and cosmonauts that need to go through the process and everything going up to the launch day itself, even up into a few hours. She's going to be up there until a few hours talking with the entire crew until they go up into space and join up with the ISS. So it's really exciting, and she's